So it's possible for a system of equations in three variables to have either no solution or infinite solutions. And in these examples, those different types of things are going to happen. So just by looking at the equations, they don't look the same at all. So I wouldn't be able to really tell from looking at them that something weird would happen. So what you would do, anytime you have a system that has three equations, it honestly looks like scary to see all of these things and how would I even solve this? So what you're doing is looking at all of the x's, all of the y's, and all of the z's first. So I see 1x at the first equation, 2x, and 1x at the third equation. I kind of like that because they're all positive. I can take 1x and turn it into a 2x or turn it into a negative 2x. Same thing with this one. So I kind of really like the x's. The y's I don't like as much just because I see like negatives. I'm not really into it. I don't know. Sometimes I would rather see positive numbers just to look at, but I can take like this y and turn it into a 2y. It's okay. And the same thing with the z's. The z's are all right too because I see 1, 2, and negative 3. So looking at the three options though, you're going to start to train your brain to pick which variable you like the best to eliminate. I'm pretty confident that I would prefer to eliminate the x's first. So I'm going to choose to eliminate the x's, but you don't have to do that. Not every equation needs to go the same way. Like somebody else could eliminate the y's if they want. Somebody else can eliminate the z's. Like that's your option, which is kind of different in math. Usually there's only one way to get an answer. There's one right answer. There will only be one right answer, but there's many ways to go about it. I'm going to choose to eliminate the x's. That means that I'm going to take these equations and I'm either going to add them together or subtract them or multiply then add them or multiply then subtract them to eliminate the x's. So let me look at equation 1 and equation 2. So equation 1 is x minus 3y plus z equals 1. And equation 2 is 2x minus y minus 2z equals 2. First thing I want to do is eliminate one of these variables so that I have two variables left. In order to do that, and I chose the x's, in order to do that, I need to take this first equation, x minus 3y plus z equals 1, and multiply it all by a number so that it'll cancel out with a 2. So the number I'm going to multiply everything by so that its opposite is negative 2. That means that I'll multiply all of these terms. So it's four things I'm multiplying by a negative 2. You just have to be very careful. I'm going to rewrite that below this equation here. So I'm going to take that equation, multiply everything by negative 2. Negative 2 times x is negative 2x. Negative 2 times a negative 3y is a positive 6y. Negative 2 times 1z is negative 2z equals negative 2 times 1 is negative 2. All right, so once I have all of that, I did that specifically so that when I add these equations straight down, the x's are going to go away. So 2x plus negative 2x cancels out, eliminates. Now I'm only going to have two variables left, which is easier for me because that's what we're used to from the last section. Negative 1y plus 6y is 5y. Negative 2z plus negative 2z. Just be very careful with these because you can get these answers like you can mess this part up and it's just simple little math. Negative 2 plus negative 2 is negative 4z equals 2 plus negative 2 is 0. So what I did here is I took equation 1 and equation 2 and I eliminated x from those. So that was equation 1 and equation 2. Now what I'm going to do is choose another combination of equations to eliminate x from. You need to do this process 2 times so that you get two separate equations. So you can do equation 1 and 2, 2 and 3, or 1 and 3. I kind of like as my second one, like the first one I did was 1 and 2. This is 1 and 2, I eliminate it. You can either do 1 and 3 now or 2 and 3. It's up to you. I kind of like equation 1 and equation 3 next. So I'm going to write equation 1 down, which is x minus 3y plus z equals 1. And equation 3 is x plus 2y minus 3z equals negative 1. So this is equation 1 and equation 3. You could have used equation 2 and 3 as well, but I just like this better. I like this better because the x's are the same. Because they're the same, instead of adding them, I could actually just subtract and not have to multiply anything. And if I subtract, the x's are going to cancel out because 1x minus 1x goes away. The only thing that's a little bit difficult is when you're subtracting, you have to be very careful with like what numbers you're subtracting, and sometimes negatives will like turn positives if you're subtracting a negative, so just be careful. Negative 3y minus 2y is going to be negative 5y. 1z minus negative 3z, that's where it gets weird, like 1z minus negative 3z. You have to be very careful with this part. This is going to turn into 1z plus 3z, which is 4z's, equals 1 minus negative 1. That's another one's going to be weird. 1 minus negative 1 really is 1 plus 1, which is 2. So you have to just be careful with those little tricky parts with the negatives. So you always take the top number, then subtract the second number. And if you have double negatives, then weird things are going to happen. So what we did so far, let's go back. We took equation 1 and equation 2 and eliminated x. We got this equation here. This is our new equation. Then we took equation 1 and equation 3 and also eliminated x, and this is our new equation. Now, we take these two equations that we just created from eliminating both x's, and we use this as our new system of equations. So I'm going to write 5y minus 4z equals 0, and negative 5y plus 4z equals 2. Once you have these two new equations, you rewrite them as your new system, and now what you would do is solve this system using these two new equations. Now, when I go to solve this system, if I wanted to eliminate y or eliminate z so that I can solve for one of the variables, I realize that something strange is going to happen, because if I actually just add straight down, 5y plus negative 5y cancels out. Negative 4z plus positive 4z cancels out. This whole entire left-hand side is 0. And 0 plus 2 is 2. So something strange, like I said, was going to happen in this problem. Usually what would happen is you would then have to use elimination to solve for one of the variables, and then once you have one of them, you could use elimination or substitution to solve the rest. But this strange thing happened because all of the variables canceled out, and I'm left with a false statement. 0 does not equal 2. So from previous examples and previous problems in different chapters, whenever we get all the variables to cancel out and you get a false statement, what is the answer?
No solution.
Correct. So this has no solution. So this means that all three of these lines don't ever cross the same point. So kind of like if you're looking at like the classroom walls, like there are no three of those lines. If this was one of the lines, this was one, and this was one, they don't ever cross all together at one point. Okay. So something strange will happen at the next one as well. You're probably already thinking what it's probably going to be, but let's see here. So I'm going to look at equation 1, equation 2, and equation 3, kind of see what I like. So I see the first equation has x plus y minus 3z equals negative 1. This one doesn't have an x, just has y minus z equals 0. And this one, negative x plus 2y equals 1. Now, for this process, we have to do this we have to take two different equations and eliminate a certain variable. So for this one, because there's only two x's and not three, we're not going to want to choose that to eliminate. Because there are only two z's and not three of them, we're not going to want to eliminate that. We're going to want to go with the y's. So for this one, we're going to eliminate the y's. So if I want to use equation 1 and equation 2 first, I can do that. So I'm going to rewrite equation 1 and equation 2. So equation 1 is x plus y minus 3z equals negative 1. And equation 2 is y minus z equals 0. What we're we're doing here is we're going to be eliminating y. If I look at this equation, I can actually take these and eliminate y without having to multiply anything. Would I add these two equations or subtract them? Subtract. Yes. Because they're both the same, y and y, if you subtract them, subtracting one minus another one will cancel it out. So we're going to subtract from top to bottom. X minus, there's nothing here, so it's just going to be x. Y minus y cancels out, and then just be careful with this. This is a negative 3z minus negative 1z. So negative 3 minus negative 1 will turn into negative 3 plus 1. Negative 3 plus 1 is negative 2z. Equals, and you can always use your calculator to help you. Just take the coefficient numbers and put them in. Just do negative 3 minus negative 1. It'll give you the answer. And then negative 1 minus 0 is negative 1. Okay, so what we did is we took equation 1 and equation 2 and eliminated y. Now we have the option to do 2 and 3 or 1 and 3. Let's take a look at them. So 2 and 3, I see 1y and 2y. And 1 and 3, I see 1y and 2y. It actually really doesn't matter. Let's just do 1 and 3. So I'm going to take equation 1 and do x plus y minus 3z equals negative 1. And equation 3 is negative x plus 2y equals 1. Now this one I'm not going to be able to just add or subtract to cancel out the y. I'll have to take the first equation and multiply every term so that it will cancel out with a 2y. Because this is a positive 2, and I prefer to combine like terms, which is actually addition, I'm going to choose to multiply all the terms by negative 2 so that it will be directly canceling out with a positive 2. So I'm going to take all of these terms and multiply them all by negative 2 and rewrite them underneath of this equation. Negative 2 times x is negative 2x. Negative 2 times y is negative 2y. Negative 2 times negative 3z is a positive 6z. Negative 2 times negative 1 is a positive 2. So I have equation 1, which is the top one. I just multiplied it by negative 2. Now it's the second one, the bottom one here that I have. And equation 3 is this one right here. If I now add these two equations straight down, the y's are going to cancel out since 2y plus negative 2y is 0. So this is going to be negative 1x plus negative 2x, that's negative 3x. There's nothing here, so 0 plus 6z is just 6z. And 1 plus 2 is 3. All right, so now we have these two equations. So for these two equations, now what we have are x's and z's. What I'm going to do now is take these two equations and I'm going to solve these two things using elimination, or you could choose substitution, doesn't really matter at this point. X minus 2z equals negative 1. And negative 3x plus 6z equals 3. All right, so at this point, now I only have two variables. This is what we're used to seeing. Hopefully no one's brain is like exploding right now. This is a lot. It's very confusing, and I promise you once we get to the next section, it'll make more sense once we can just put it in the calculator. But we have the option now. Technically, with this method, you're supposed to continue on with elimination. So now you have the choice to either eliminate x or eliminate z. It's up to you. If I go ahead and try to eliminate x, I'm going to multiply this whole thing by 3. I'm going to multiply this all by 3. When I do that, that turns into, I'm going to write it underneath of here, it turns into 3x minus 6z equals 3 times negative 1 is negative 3. Then using the elimination method, I would then add straight down, and then something strange happens. Negative 3x plus 3x is 0. 6z plus negative 6z is also 0, so that whole left-hand side is 0. 3 plus negative 3 is 0. So once I got to that point, I didn't see it right here. Like when I was looking at these two, I was like, oh, I guess this isn't an infinite solution problem. But once I did the elimination step, I saw that the answer would be infinite solutions because all of the variables ended up eventually canceling out, and we're left with a true statement, 0 equals 0. So I believe that's all of the problems in this section. The next section is 4.4. So we are going to